This network demonstrates the following 7 networking concepts. 1. Configuration and use of DHCP v4 in a multiple VLAN environment where one router provides DHCP service to 2 VLANs. 2. Inter-vlan routing. 3. Static routing. 4. Default static routing to define a gateway of last resort. 5. Use of a local DNS server. 6. Network address translation and port address translation and static network address translation. And 7. Access to a server in the DMZ area. We'll demonstrate network functionality by verifying 1. DHCP configuration of PC0 and PC1 in VLAN 10 and PC2 in VLAN 20, accessing the www.fastnet.com server from PC0, PC1, and PC2 using the URL. 3. Access to the customer service server from PC0, PC1, and PC2 using the internal address 10.1.1.3, and access to the customer service server from the customer PC using 209.165.200.1. We will also use the following show commands to verify our static routing, show IP route, to verify DHCP operation, show IP DCP binding, and show IP DCP pool, to verify network address translation, show IP NAT translations. 5 questions to keep in mind as we build this network. 1. Why must switch S0 port 24 be configured as a trunk? 2. What is the purpose of the static route configured on R0? 3. What is the purpose of each static route configured on the edge router? 4. How would this network change if the DHCP server were located between R0 and the edge routers? 5. Why does the ISP router need no static routing? And finally, our local area network address space is 10.1.1.0/24. This address space is subnetted into address spaces that will reside in VLANs 10, 20, and 30. The 10.1.1.0/30 subnet will be the address space for the point-to-point connection between R0 and edge routers. Now let's configure this network. Switch 0. We're going to declare VLANs 10, 20, and 30 and assign interfaces to those VLANs 1 through 5 to VLAN 10, 6 through 10 to VLAN 20, 11 through 15 to VLAN 30. Port 24 will be the trunk. Okay, no errors. On router R0, we're going to configure G01 as 10.1.1.2, and notice the mask. It's a /29 subnet mask, so we can have up to 6 hosts. We need 3. And then the sub-interfaces, .10, .20, and .30 off of G00, they'll support the VLANs. Now also on router 0, we're going to configure DHCP. We're going to configure an excluded address range for VLAN 10 and VLAN 20 address space. And we're going to configure the address pool for VLAN 10 and VLAN 20. And finally, on router R0, we need to configure a static route to a default gateway. Our gateway of last resort will be the next router, edge, at 10.1.1.1. And so that completes our configuration of router R0. Now let's look at edge. First, we'll configure the interfaces on edge. G01 will get 10.1.1.1. It's connected to the local area network, and notice this is a /29 subnet. It's this area right here, and it also is connected into the area that's going to be our DMZ. Now in this DMZ, we have a customer service server that will be accessed from the outside and from the inside. From the inside is 10.1.1.3. From the outside is 209.165.0.2. On the outside of Edge, we're going to configure 209.165.0.2, which is also going to be used for our network address translation address. And we also have 3 static routes on the Edge router. 2 to get to the local area network that's inside of R0, and the default route, which directs all packets to a destination network that's not listed in the routing table of Edge. It'll direct those packets to 209.165.0.1. And finally on Edge, we have to configure our network address translation. Notice we define an access list for each of the local area networks, the .128 and the .160. We configure network address translation, port address translation for the local area network address space. And we configure a static translation to the customer service server 10.1.1.3, and that too will be accessed using 209.165.02. Now the outside local address on Edge will be 209.165.0.2. Now on our ISP router, the only configuration that's needed is the configuration of the interfaces. No static routing is needed on the ISP. And now our network is configured. First, let's verify that PC 0, 1, and 2 are configured by the Dhcp server. Here we have PC 0 has .135, and that's what we would expect. PC 1 has 134. That tells us that PC 1 got its DHCP configuration before PC 0 because our pool started at 134 because we excluded addresses 129 through 133 for VLAN 10. Notice we also have the DNS server configured at 195. Let's fix this. This should be 195 down here. Because this is on VLAN 30, and VLAN 30's address space is beginning at 192. Okay, let's look at PC2. 166, and that's what we expect because we reserved or excluded addresses 161 through 165, and the DNS server is configured as 195. Now let's verify the functionality of the remaining items in this network. First, we'll verify access to fastnet.com from the PCs in the local area network. Then we'll verify access to the customer service server from those PCs in the local area network using the internal address 10.1.1.3. Then we'll verify access to the customer service server from a customer PC using 209.165.0.2. Okay, access to fastnet.com from the local area network, PC 0. PC 1. And PC 2 from VLAN 20. Okay, now access to the customer service PC using its internal address 10.1.1.3. Customer service. Customer service. And customer service. Now let's verify access to the customer service PC from outside of the customer site using the outside local address. Okay. And finally, we want to look at Edge and look at the NAT translations as they occurred. Notice these are the dynamic entries in the IPNAT translations table. This is a static entry. This never goes away. That concludes our demonstration of the functionality of this network. And now, students, this is what you're going to receive, this file here, and also the configuration for each network device here, switch 0. Here's router 0, R0. The last configuration item for router 0 is the default route configured to go to the edge router. The edge router and the ISP. That concludes this video.